Those cartons end up here. Now the cycle of rebirth begins. It starts with the same trash pickers who collect aluminium cans. São Paulo's catadores retrieve the Tetra Pak and haul it to a collection center. Here they salvage all kinds of paper, including cardboard. Brazil is one of the largest cardboard recyclers in the world. It recycles 76% of all the cardboard it produces. The collection center breaks down the Tetra Pak containers and bales them for transport to a paper plant. São Paulo has one of the largest paper plants in the world, Klabin. Like Tomra's aluminium recycling plant, Klabin operates 24 hours a day, 7 days a week. Each day, it produces 200 tons of recycled paper. The ingredients: 3 parts corrugated cardboard, 1 part Tetra Pak.
This whole factory works based on recycled material.
The material goes into a large blender called a hydropulper. Water turns it to pulp. During agitation, the paper in the Tetra Pak separates from the layer of plastic and aluminium, which are sifted out for use later. After about 20 minutes of agitation, the hydropulper recovers more than 90% of the paper fibers in a Tetra Pak carton. Those fibers now become paper again, new and improved.
When you add the fiber of the Tetra Pak container, you improve the quality of the recycled paper. Why? Because the fiber of the Tetra Pak container is virgin and the cardboard fiber has been recycled many times.
Almost every paper fiber that entered the hydropulper ends up as recycled paper, destined to become cardboard boxes.
This is the end of the process.
Not quite. The rest of the Tetra Pak carton waits to be recycled. Fused layers of aluminium, plastic and paper residue, inseparable and unusable. Yet while other cities threw this residue away, São Paulo invented one use: roofing tiles. They finally shred the plastic aluminium residue, then press it on a corrugated mold. The tiles are hard to top, tough, durable, waterproof, heat-resistant, and up to 10% cheaper than regular roofing tiles.
These tiles are extremely light and efficient. Today we have 11 factories making these tiles around Brazil, using 700 tons a month of plastic and aluminum from the Tetra Pak containers.
Separated, the plastic and aluminium would be even more valuable. But leaving the hydropulper, they're inextricably mixed. Scientists can split the atom, yet for years, no one could pry apart Tetra Pak.
We ended up sending this material to landfills, not only wasting important raw material, but also causing an environmental impact.
Roberto Zente is technical director of TSL Environmental Engineering. They gave him a mind-boggling mission: crack the Tetra Pak enigma.
This is the problem. You have a thin layer of aluminium. You can see how thin it really is. Sometimes it's even transparent. And another layer of plastic. This aluminium, because it's so thin, it oxidizes when it's exposed to air.
In other words, it rusts. And rust creates a catch-22. To break up the oxide and recover the aluminium takes extreme heat. But extreme heat can destroy the plastic.
So the hard part is to recover the aluminium, which requires high temperatures, and at the same time transform the plastic into a usable product.
Working with a consortium in São Paulo, Zente finally cracked the problem. The technology is so new, the first full-scale plant has just come online. This test site demonstrates the ingenious solution.
O material ele é colocado
The material is put here and fed through a piston. Then it enters a reactor where the process starts.
The reactor isn't nuclear, it's plasma.
Plasma is a gas heated by electric energy in the shape of an electric arc. Those old Frankenstein movies where you see a sphere send an electric charge to another sphere, that's an electric arc.
Like Frankenstein's lab, the plasma reactor produces a transformation that long eluded science. An electric arc creates a plasma jet, superheated to 15,000 degrees Celsius, almost 3 times the surface temperature of the sun. The plasma jet dissolves the stubborn bond of plastic and aluminium. Paper residue burns away, and like magic, wax and metal separate. The plastic emerges as a gas to be turned into paraffin wax. The aluminium emerges as molten metal, 99% pure. Emissions during recovery, almost nil. A monster of a problem solved by Frankenstein's technology. The plasma breakthrough revolutionizes recycling in São Paulo. For the first time, all 3 Tetra Pak components, paper, plastic, and aluminium, will return to the production chain as raw materials, bringing the cycle full circle. The breakthrough brings a windfall. The value of a used Tetra Pak carton could increase up to 30%. Now, São Paulo is exporting its recycling know-how throughout the world, even to technological dynamos like Germany.
This way, we were able to introduce Tetra Pak recycling in many countries where it didn't exist, simply by adapting technologies developed here in Brazil.
Yet an ugly obstacle to recycling persists at home, right in São Paulo's backyard. Waste on a grand scale. Costly, ugly, and lethal. How do you recycle a city that already died? In the 1980s, hell on earth had an address. An industrial center outside São Paulo. Cubatão earned an infamous title, the most polluted place on earth. Less than 60 kilometers from the heart of São Paulo, steel mills, chemical plants, and fertilizer factories spewed a lethal brew day and night. Pollution defoliated the surrounding mountains and triggered mudslides. The Cubatão River died. Cancer rates soared to 6 times the norm. Babies entered the world with birth defects, without brains, stillborn.